आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
In this question, we need to evaluate limit x tending to 0, 1 by x, integration from y to a, e to the power sin square t dt, minus integration from x plus y to a, e to the power sin square t dt. So let us denote this as I. So I can be written as limit x tending to 0, 1 by x, integration from y to a, e to the power sin square t dt. Now we will interchange the limit of this integral. So a minus sign will appear and minus minus will become plus, and so plus integration from a to x plus y. We have interchanged the limit of this integration, e to the power sin square t dt. Now we know one thing, that for integration from a to b fx dx plus integration from b to c fx dx can be written as integration from a to c fx dx, since the upper limit of this integral and the lower limit of this integral is same. So similarly, here in place of a we have y, in place of b we have a, and in place of c we have x plus y. So I can be written as I equals to limit x tending to 0, 1 by x, integration from y to x plus y, so y to x plus y, e to the power sin square t dt. Now note one thing, that when limit x tending to 0 fx by gx is of the form 0 by 0, then according to L'Hospital rule we can say that this will be equals to limit x tending to 0 f dash x divided by g dash x. Similarly, we can see that this is also of the form 0 by 0, where fx is equals to this integral and gx is equals to x. Now how fx is 0 when x tends to 0? When we put x equals to 0 here, the limit of this integral will be from y to y, and we know that integration from a to a fx dx will be equals to 0. So similarly, when x equals to 0, this integral will be equals to 0. Also at x equals to 0, this x will be equals to 0. So we can say that this I is of the form 0 by 0. So this can be written as I equals to limit x tending to 0 ddx of the this part, that is ddx of integration from y to x plus y e to the power sin square t dt divided by ddx of x. Now ddx of x will be equals to 1, and we will differentiate this integral using Leibniz integral rule, which says that ddx of integral ax to bx ft dt is equals to f of the upper limit of the integral, that is f of bx, into b dash x minus f of the lower limit of the integral, that is ax, into a dash x. So similarly, we can say that the ddx of this integral, this one will be equals to limit x tending to 0 f of, that is e to the power sin square of the upper limit of the integral, that is x plus y, into differentiation of x plus y, that is 1 plus dy by dx minus e to the power sin square the lower limit, that is y, into ddx of y. So dy by dx, and dx by dx will be equals to 1. So now we'll put the limit. So this will be equals to e to the power sin square y, since we have put the value of x as equals to 0, into 1 plus dy by dx minus e to the power sin square y dy by dx. So this will be equals to e to the power sine square y, since this one and this one will get cancelled out. So we got the value of I as e to the power sine square y. And I guess these options are not for this question. I've added it by mistake. So this value of I will be equals to e to the power sine square y. This is our final answer.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।